So now we're talking about the surface area of pyramids and cones. And here's a nice example, the typical pyramids of Egypt, of what a pyramid is. So what I want to point out to you is that a pyramid only has one base, and then all of the lateral faces meet together at one point called the vertex. And that's why we only have one base, because those faces meet at a point rather than at another base. So we have a lot more going on in a pyramid. Notice that the lateral faces are all triangles now. So we're going from the edges to the base to a point, which is why all of them are now triangles. We still have a lateral edge, which is where the two faces meet. So that's where each triangle meets. We have a base edge, that's where the lateral face meets the base. And then we have the altitude of the pyramid. So that's going perpendicular from the base straight to the vertex. So we have to be careful there when we talk about height. Do we mean the height of the whole pyramid, or do we mean height of just a triangle and things like that? So we'll talk about more of the vocabulary we use for that. There's another example of a pyramid. It's on the Louvre. And I want to discuss next the nets for a pyramid. So I'm going to skip this next slide, go to a net. So if I take a pyramid, so this is a square pyramid because the base is in the shape of a square. Notice that we have all these triangles. And if I were to fold it out, it would look like a square with triangles coming off of it. Okay, so that's what a typical net of a pyramid looks like. So if I'm finding the surface area, I'm finding the area of the base and then the area of all the triangles. So if I look at the triangle, I'm going to have, if I call S the side of one of the base, and then L, I'm going to call L. L is for slant height. So notice that fancy L is what we're calling slant height, because when we fold it all up into a pyramid, that is actually a diagonal, right? It looks slanted. So, but when I fold it out, it looks like just the height of the single triangular face. So the area of one of these triangles is 1/2 base times height, or 1/2 S times L. So the other thing I said was the altitude. So when we call height, or H, we're referring to the height of the pyramid. So the two different heights, H is the height of the whole pyramid, and slant height, L, is the height of the triangular faces. Okay, so now let's go back to the formula. So if I add up all of these triangles, S is going to be the base of the triangle. So, and I'm going to have as many sides as there are sides of the base. So if I have a square, I am going to have 4 S's. If I had a pentagon, I would have 5 S's and 5 triangles. So in our formula, if I'm talking about lateral area, I'm going to be doing 1/2 perimeter times L, the slant height. And the perimeter is coming from the number of triangles I have. So that's just going to be our S times the number of sides. So again, that's the perimeter of the base. P is still the perimeter of the base. L is that slant height. All right, so then if I add all those triangles, see, these are the lateral area is the area of all the triangles. And then remember, I'm just adding one single base, so I don't have 2B in my formula this time. I only have one single B. So B, again, is the area of the base. So let's do an example. So here I have a pyramid. I know it's a pyramid because I have a single base and it comes to a point up here. So I'm first going to identify the shape of the base. The shape of the base is this square. And we are going to be assuming for most of these that the base is a regular polygon. That's so that we know all the sides are the same. So our surface area formula is 1/2 perimeter times slant height plus B. So I need to find all of those pieces. So the first thing, P. P is the perimeter of the base. Each side is 90, so that's going to be 90 times 4 since it's a square. And that would be 360. All right, L, did they give us L? Do you see how L would be? We don't know. It's right here. We don't know this slant height. So that's going to be something we have to find. So L we'll find in just a minute. And then the B, the base, is going to be the area of the square. So that's just going to be 90 squared, or 90 times 90. Okay, so that'll be 8,100. Now let's go back to that slant height. We don't know what this is, but what they did tell us was the height of the whole pyramid. So we know the height of that whole pyramid. Do you see how this makes a right triangle? And so I'm going to redraw that right triangle. So I can do Pythagorean theorem using that height, the h height, the 97, and finding this other leg of the right triangle. Now, if this is 90 all the way across, then that triangle would be half of that distance, because that would be 45, and that would be 45. So I'm finding the hypotenuse, which is going to be the same thing as my slant height right here. Okay, so all we're doing is Pythagorean theorem. So 97 squared plus 45 squared is going to be equal to our slant height squared. So let's do that. 97 squared is 9409. 45 squared is 2025. Let's add those together. And I get 11,434. And now I'm going to square root that. And this gives me approximately 106.93. Okay, so again, if we wanted to be more exact, we could say that the slant height is the square root of 11,434. If we're approximating, we're going to use 106.93. However, in reality, I would really like to save that rounding to the end. So let's use the square root of 11,434 for our formula. So that's going to be 1/2 perimeter, which was 360, times the slant height, which is square root of 11,434, plus the 8,100. So if I do that times 360 divided by 2, now we can round. Okay. Now I'm going to round. This came out to be 19,247.38 plus 8,100. And remember, when I add 8,100, that will not affect my rounding. It's just when I multiply and divide and things like that. So my final surface area is 27,347.38 meters squared. So there we go. We've got the area, the surface area of a perimeter of a pyramid. And so now let's look at a cone. A cone is just a pyramid with a circular base. So we still have h, which is our altitude of the pyramid, our radius of the circle of the base, and then we have our slant height. And here's an example of a net of a cone. So it's going to look like a sector and then a circle. And again, so we're going to have pi RL, so instead of 1/2 our perimeter, remember a perimeter of our base would be 2 pi r, and if I take half of that, it's just going to be pi r. So it's going to be 1/2 pi, or 1/2 times, here I'll write, we did this. So I did 1/2 times 2 pi r, that gave me pi r, and then times the slant height. So that's our lateral area, and then we're adding one base, which is the area of the circle. Okay, so in our cone, all we need to know is the radius and the slant height. All right, so let's do an example. So for surface area, we're going to be doing pi RL plus pi r squared. My radius in this one is 3, and this time they did give me the slant height, so that one's pretty easy. But again, you have to be ready to do Pythagorean theorem if they don't give you the slant height. So my surface area is going to be pi pi times 3 times 5 plus pi times 3 squared. So this is going to be 15 pi plus 9 pi, since they're both pi's, add them together. And that's going to give me 24 pi meters squared for our surface area. And there we go. So we'll do a lot more examples and we'll get harder in class.